Absolute value functions and graphs. For graphing absolute value functions, we're going to use the general form of the equation here. Y equals A, absolute value x minus h, absolute value plus k. So remember, this is a subtraction and this is a plus sign. You need to make note of that subtraction and plus sign in the general equation, especially as we talk about the vertex, because the vertex will always be the coordinate point h, k. So by default, h will be a negative number. So if you see minus h, h is actually going to be a positive number. And then if you see x plus h, that h is actually a negative coordinate point. And then for k, because it's default a plus sign, this one just follows. If it's plus k, then it's going to be a positive k coordinate. If it's minus k, it's a negative k coordinate. So make sure you pay attention to that. On the parent graph, the vertex is going to be the origin. So I'm going to go ahead and mark the origin right here. Okay. Next, let's talk about the opening. The opening is going to be based on the letter A. If A is positive, it's going to open upward. If A is negative, it's going to open downwards. Okay? On the parent graph, it opens upwards. Okay? When we talk about the width is going to be based on the absolute value of A. So we don't care whether A is positive or negative. That's really for the opening. It's just whether it's positive or negative. We don't care about the actual number A. For the width, we care about the number and not the positive or negative value. So if the absolute value of A is less than 1, then this is going to be wider. This is just a hint. And then if the absolute value of A is greater than 1, this is going to be thinner. Okay. So on the parent graph, we're going to talk about the absolute value of A actually equals 1. So I'm going to show you what that looks like. So when the absolute value of A actually equals 1, like we said, we have vertex at the origin, and the sides just have a slope of positive 1. So there's one side, and here is the other side. So your absolute value function is going to be a V. Okay. So you need to familiarize yourself with the parent graph. Like I said, this has a slope of positive 1 on this side, a negative 1 on this side, but if it's a V and it goes up 1 over 1, up 1 over 1, with vertex at the origin, and it opens upwards, this is your parent graph. So next we're just going to go through a set of different example problems to get in some practice. So I'll work some of these out with you, and I'll have you work out some of these on your own, but you will need graph paper. So we're going to graph the functions and then write down the domain and range using interval notation. So first, we need to graph the vertex. So the vertex is going to be our h, k. We don't have an h, so that's just going to be 0. So I'm just going to mark that here. The vertex is going to be 0, and then our k is positive 2. So our vertex is 0, 2. So this is where it starts. Then we look at our A to see if it's positive or negative. It's positive, so we know it's going to open upwards. Now, our A is also 1, so we know that that's going to have a slope of positive 1 going to the right, and it'll have a slope of negative 1 going to the left. Okay, so this is our graph. Now, let's go ahead and write the domain and range. So the domain, going in the negative direction, we will always have this graph going towards the left, so we have a negative infinity for our smallest value. Our graph will always go towards the right in the positive x direction, so we have positive infinity. Now for the range, our very lowest value, our y value, is 2, and it includes 2, So we use a bracket for 2, but it's on both sides, left and right, it's going to go up forever in that positive direction. So our highest value is positive infinity. Okay? Now, I want you to follow those steps in the same way. Try example 2 and come back and check with me when you're finished. So for the second example, hopefully you found the vertex is 0, -1, and it opens upwards. So you plot that vertex, and then we're going to have that slope of +1, -1, that v opening upwards. The domain is -infinity to positive infinity, and the range is -1 to positive infinity. Okay. Now let's try this third example together. So again, our vertex HK is 0, +3. So let's go ahead and mark that 0, 3. And then this negative tells us that it's going to open downwards. We don't have any other changes. So all we're going to do is we're going to take that positive slope to the right, and we're going to open that downwards, making that a negative slope of 1 down to the right. Okay, so instead of going up, we're going down. And then same with on the left side. Instead of going upwards, we're going to take that slope and make it a positive slope down to the left. So it's that v just flipped upside down since we have that negative. Now when we do the domain and range, again, the domain is going to be -infinity to positive infinity, and the range, this time the lowest y value, it's actually going to go down forever. So our lowest y value is -infinity, and the highest y value we have is +3. So we're going to close that with the bracket. In this next set of examples, I'll go through this first one with you. Okay. So again, we want to list the vertex, which is going to be h. And remember, we said this one, it's supposed to be a subtraction default for the general equation. So it's always going to be the opposite of what that looks like. Since this looks like +2, that h, our x-coordinate of the vertex, is actually -2. We don't have a k out here, so it's just going to be 0. And then our a is positive, so it opens upwards. So we have a vertex of -2, 0, and we know it's going to open upwards. We don't have any other adjustments to make. So this is going to go up to the right with a +1, and then up to the left with a slope of -1. Okay. And then we just need to write our domain and range. Again, we're going forever to the left and forever to the right, so it's -infinity to positive infinity. And then the range, the lowest y value is this 0, and it is included, so bracket 0, and then it'll go forever upwards, so it goes to positive infinity. Now go ahead and pause, try example number 5, and then check back with me and see how you did. So hopefully for example 5, you got the vertex is +1, 0. Remember how we talked about this. It's supposed to be a negative in there. So if it says -1, it's actually the opposite, +1. Okay. It opens upwards, so we plot the vertex at 1, 0, and then we have that slope going to the right, +1, going up to the left, -1. Your domain is -infinity to positive infinity, and your range is 0 to positive infinity. Now, example 6 has all of the elements we've worked with so far. A -a, an h, and a k. So I want you to go ahead, try this one on your own, take all the steps, combine them together, and see if you can do this. Check back with me when you're finished, and we can check your answers. So for example 6, hopefully you found that the vertex is -3, -2. Remember, the inside one, your h, it's always the opposite symbol of what it looks like. The outside one, your k, is the same symbol as what it looks like. Because our a is negative, it's going to open downwards. So we plot our vertex, and then we're going to open downwards. So it goes down to the right at a slope of -1, down to the left at a slope of positive 1. Our domain is going to be negative infinity to positive infinity. And our range is negative infinity, because it'll go forever down. And then our highest y value is going to be negative 2. So we close off the bracket at negative 2. In this set of problems, we need to decide whether the graphs of the functions below are wider, narrower, or the same width as f of x equals absolute value of x, the parent function. So this first one, it looks almost exactly the same. It's just going to be reflected downwards. So we still have vertex at the origin, and then instead of opening upwards, we're going to open down. So to the right, it'll go down at a slope of negative 1, and to the left, it'll go down at a slope of positive 1. Now, because we didn't do anything to change the width, it's just reflected upside down, this one is going to be the same width as the parent function. Now, this next one, we have this 1/2 out in front. Okay, and we talked about the absolute value of that a for example 8 and 9. Now I'm going to show you an easy way to do this. Our origin is the same, so we're going to plot that. Now, you're actually going to use this a as your slope to find your next point. So from the origin to the right, we're going to go up 1, to the right 2. So rise 1, run 2. Now, the only thing about on the left side is we're not going to go down 1 over 2 to continue that slope. We know that this needs to be in a V, so we're actually going to mirror it on the other side. So if we went up 1 to the right 2, we need to go up 1 to the left 2, so we have that same point on both sides of the origin equally. Then, when we connect those, we'll get that V shape that we wanted, okay? And this one ends up being wider. So remember, we talked about the fact that when the absolute value of a is less than 1, this is actually going to be wider. Now this one, we have 2. We're going to graph it the same way. Our vertex is the origin, and then use this to get the slope to the right side. So it's going to be up 2 over 1. And now we want to mirror it on the other side of the vertex. And then we'll connect that to make our graph, because we know it needs to be in a V shape. And then this is going to be narrower. So this is like what we talked about on the very first page. If the absolute value of a is greater than 1, this is going to be narrower than the parent graph. Now let's do a couple examples graphing with either the wider or the narrower version. Okay? So we're going to take this first one, do what we did before. First, find the vertex. So remember, opposite symbol of the inside, same symbol as the outside. A is positive, so it's going to open upwards. So we plot our vertex 1, negative 2. And then from here, we're going to use that as our slope to get our next point. So we go up 3 to the right, and then to mirror it, up 3 and 1 to the left. And then we'll plot our graph. And then we need to write our domain and range. Domain is negative infinity to positive infinity. And then our range, our lowest value for the for the y is negative 2. And then our highest value, it'll go on forever, so we have positive infinity. Now I want you to take that same idea, do this next example. Don't forget about this negative here, so that tells us it opens downwards. Try this one, and then check back with me when you're done. So for this one, your vertex should be negative 3, negative 2, and we know it opens downwards. So we plot negative 3, negative 2, and then remember, use that A to find your slope to the right, down 2 over 1, and then you need to mirror it on the other side of the vertex. And then you plot your graph. Domain should be negative infinity to positive infinity. And your range, it's going to go forever in the negative direction, so it's negative infinity. And your highest y value is negative 2, so we have negative 2 closed off with the bracket. All right, let's try this next example. So this is going to be the same, except we have these a values that are less than 1, so we know that they're going to be wider than our parent function. So the vertex, again, negative 2, positive 1, because this one has to be opposite. This is negative, so we're going to open downwards. So let's plot negative 2, positive 1, and then we're going to use our slope, negative 2 over 3 to get the one on the right, and then mirror on the left, down 2 over 3 to the left, and then we're going to make that graph, plot those lines so we get our V, and it is wider. Okay, so our domain, negative infinity to positive infinity, and then our range, again, forever in the negative direction. Our highest y value is positive 1, closed by a bracket. So go ahead and try the second example, follow the same steps, and check back with me when you're done. So hopefully you got that the vertex is positive 1, positive 2, and it opens upwards. So we plot 1, 2, and then we use your slope to go up 1 over 2, up 1 over 2, and then we plot our lines for the V. Your domain should be negative infinity to positive infinity, and then your range is lowest value is positive 2, and then it's going to go forever upwards, so it goes to positive infinity. Now in these last examples, what we're going to do is we are going to actually use the graph to write the equation. So we're going backwards from what we did. So this, our vertex, okay, remember this is your HK, that's 3, 1, positive 3, positive 1, and then we have a slope of up 2 over 1, okay, so I'm just jotting down information, 2 over 1, and this opens upwards. So we need to write it in our formal equation. Y equals, since it opens upwards, it's positive. Our slope is 2, absolute value of x. Remember, opposite sign, so if this is a positive 3, we actually need to write it as minus 3. Close the absolute value. The y on the outside is the same sign, so it's plus 1. Okay? Now I'll walk through this one with you together. One more together. Vertex is negative 2, 2. So we have that slope of down 1 over 1, down 1 over 1. So that slope is really just 1. It's the same. And then it's opening downwards. So we have y equals, since it's opening downwards, it needs to be negative. But our slope is that 1, which means it's like the parent, so we're not going to put anything there. We have the absolute value, and then x minus, since this is a negative number, it needs to read opposite, so we put plus 2. The outside one, the y value is the same. And there you go. Go ahead and pause, try this last one, and check back with me when you finish. So our essential information, the vertex is negative 2, negative 1. Our slope to the right is up 1 over 2, so we have 1/2. It opens upwards, so we have y equals a positive 1/2, that's slope to the right. Absolute value x plus 2, because our x coordinate needs to be the opposite of what it looks like. Absolute value, and then our y coordinate of the vertex, minus 1, that stays the same. That's it for this video. Make sure to submit any questions if you have any on the website.